So class, for today class or for this week's class, so we will learn about integration. Okay, we are still in integration, chapter integration, but this is the new chapter lah. Okay, so integration with the different approach. If the last week class we learn about analytical, which is the common yang that you use to do integration like that. Maksudnya kita memang selalu guna integration punya how to integrate, what we learn last week lah. Okay, but for this week I think this is new for you. So this is the numerical approach. So the title of this chapter for today class or for this week class is about numerical integration. So numerical integration. So if you are still remember, for the last 2 weeks we learn about numerical differentiation. So it's similar like this, not similar in terms of formula. No, I said some formula. I said it's similar like if you can see for the numerical differentiation, they have no differentiation occur. Maksudnya they have no, macam selalu kita belajar differentiation, power, tolak satu and then letak depan and so on, right? But for the numerical itself, for numerical differentiation, they have no things such, no such thing like that, kan? Tak ada pun berlaku any yang I think there's no differentiation yang kita faham differentiation selama ni, there's not appear in the numerical differentiation, right? It's just using a formula. Okay, same thing for numerical integration. So even though the name for this title is integration, it's actually is integration, but it's not the common integration. It's the numerical. So they have no integration yang berlaku macam such as like this lah. They have no, tak ada. Okay, so same thing like the numerical differentiation before. So what you will learn in numerical integration now is all about a formula. So you are using the formula given or not given, like the formula that you learn to get the answer. Maksudnya kita akan guna formula lah untuk these topics. Okay, alright. So okay, that's the briefing about numerical integration. So what I can say that this is the numerical approach. So the different approach, okay, the different method. So they have a few methods, okay, that you will learn, such as like macam numerical differentiation before you learn about forward, backward, centered, right? Okay. So for the numerical integration, you will learn about, so they have 3 formula. Okay. The first one we will learn about the trapezoidal. Okay, trapezoidal rule. Okay, the first formula that we learn. And then what else? Okay, we have also Simpsons. Okay, maybe this one nama orang dia lah kan, Simpsons 1/3. And also Simpson 3/8 rule. Okay, this one is 1/3, this one 3/8. And for the 1/3 and 3/8, okay, maksudnya under this one, under these two, for Simpson 1/3 and Simpson 3/8, they also have a multiple, what we call the multiple of application of Simpson ni lah. Okay, same thing for this one, multiple of application. Okay, so actually for the multiple ni, there's under Simpson 1/3 macam ni kan, this is under Simpson, but the difference slightly different on the formula. Dia ada perubah sikit untuk dia punya formula. Okay, so total I can sum up, I can say that you will learn or you will have 5 different formula. Okay, alright. So I will start first with the trapezoidal. So trapezoidal, so the formula for trapezoidal is given by, okay, so this is, we represent as I, okay, integration, right? So you have equation like this. Okay, so means that you want to find the integration of a function, right? But we don't want to make, this one is the classic or analytical way lah, macam kita selalu guna kan. Okay, tapi kita tak nak guna yang ni. We want to use the trapezoidal rule. So the trapezoidal rule formula given by H/2, and then inside the bracket we have F fx naught plus dot dot dot, okay, tak payah dot dot lagi dah, okay, plus 2fx1 first, okay, 2fx1 and then plus 2fx2 plus, okay, dot 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 dot, okay, plus 2fxn minus 1 and plus fx1. Okay, so now I will brief you about this formula first. Okay, I mean I don't brief you how to get the formula, so you can refer to any what we call any sources lah. That one is about yang tu actually for you, you just apply. Okay, you just apply the formula. Okay, so you can see that they have h over 2. So h is a common. H is a step size. Okay, h is you already see it in many chapters before, right? So h is step size. And then we have fx naught, okay, plus fx2 plus, so means that dot 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 here is infinity. So this is a general formula, right? So we just assume that this number can be infinity. So, okay, I want to you see at the middle one, okay. At the middle one, you can see that all the terms will multiply with 2. 2fx1 plus 2fx2 plus dot dot dot. Okay, dot means kalau if you have another data, it will be plus 2fx3 plus 2fx4 plus 2fx5 dot 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 until you can see that before the last the last two, okay, means that this is the last one, right? So before the last term, it still plus or it still multiply with 2 fx minus 1, and minus 1 means represent any number lah, okay. Right, so you can see that all the middle one, I mean di tengah-tengah tu, bukan di tengah-tengah exactly, means that between, okay, between, the correct word is between starting and the last. Okay, starting just fx naught, no, without multiplication with 2, tak ada multiply with 2, eh? And the same thing for the last term, fx1 only, fxn only, they have no multiply with 2. So in the what we call the between this, the first one and the last one must be multiplied with 2. Okay, get it what I mean? Alright, so this is the formula. So let's say you will given in the question, you will be given how many function or how many data that you need. So you already know until how many. So let's say lah, for the question, if the question asks you or given to you until fx0 and fx1, so the formula will be h over 2 fx0, okay, plus, okay, assume they have a between here, and then the last point is fx1, right? So you have 2 point, right? So this is the first and the last one. So fx0, fx1. So in the middle, ada tak? So they have no lah, because you just have 2 data. Okay, you just have 2 data. So what you need to do first, you just log in the first and the last term first, and then the balance baru you letak in between. So means if you doesn't have any between that one, so means that if tak ada lah, doesn't have any lah. So means that your formula will be h over 2 and then fx0 plus fx1. Okay, alright. So maybe you didn't see clearly yet. Okay, but I give you another one. Let's say you have up till fx2, let's say, so mean that the formula will be fx0 plus, and then the last one is fx2, the last one, and then what's the middle? Apa yang di tengah-tengah ni? What's the between the first and the last? It will be fx1, right? And this fx1 must be multiplied with 2. Okay, so this is the formula one. The formula for the correct one, kalau if you have 3 data. Let's say if you have 4 data, you have like until fx3, so the equation would be h over 2 fx0 plus, and then in the end fx3. Okay, and then what's the in the between one? The between you will have fx1 and fx2, so 2fx1 plus 2fx2. So this is the formula for trapezoidal. Okay, this is the formula for trapezoidal. So I will show you the example. Okay, so example So the question asks you use trapezoidal rule to integrate numerically fx equal to 0.2 minus 2x squared plus 40x power 5, okay, from a0 to to b equal to 0.8. Given that your h is 0.2. Nampak tak? Okay, silau okay, tak apalah. I will read it for you. So the question here is use trapezoidal rule to integrate numerically fx equal to 0.2 minus 2x squared plus 40x power 5 from a0 to b0.8. Okay, so the first point, the starting point will be start from a0 and then the last point will be end with 0.8. Given that your h is 0.2, so this is your question. So actually all the data that you need already given here. Okay, cuma you tak dapat bayang lagi macam mana nak buat. Okay, so for now you need to know the formula for trapezoidal first. So h over 2 and then inside the bracket we have fx naught plus 2 blah 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 until plus fxn. Okay, so what you need to do first is you write down your data. So it say that it start from 0 and what we call end with the 0.8. So kalau you maksud dia macam ni, equation dia macam ni 0, 0.8 and this is your function and then you integrate. So please don't do like this. I mean this is just, yeah, this is correct one, but this is analytical approach. The question asks you to do the numerical approach. So please don't get confused. Please get it clear, okay? Antara or between analytical and also numerical. So if you still need to know this one. Still, if the question asks you to compare or to find the error. So if the question asks you to find the error, means that you need to find this one. By using this one, you get the answer. And the answer that you get here is a true value. Okay, the answer that you get by using this numerical is a approximation value. Get it what I mean? Okay, maksudnya kalau if the question asks you to find error, let's say the question asks you to find error between these digits, so you need to have a true value, right? Which is true and also approximation. So from here, from this question, you calculate, you will get the value, but that one is approximation value. Okay, for the numerical approach, you will get only approximation value. To get the true value, you need to do this one. Okay, this is the analytical approach lah. So you still need to know it. Okay, still kena tahu. Okay, even though you belajar sekarang ataupun we in this chapter numerical, but you still need to apply this one kalau if the question asks you to find error. Alright. Okay, so we back to the question back. Okay, so this one the first point and this one is the last point. And what is your step size? Your step size just now is 0.8, right? So x naught is equal to a lah. X naught is the starting point. So your a just now is 0. And then your h is the step size, right? Step size means the gap between h. So your step size is 0.2. So what's the next point of x1? Would be 0.2. What's the next point of x2? 0.4. x3 0.6. x4 0.8. You need to continue or not? You need to continue? Okay, you just leave it or you just stop it until here because this is your end point, which is this is your B, right? So you need to know lah bila you nak start and bila you nak end. Okay, make sure that one will be clearly given in the question. Okay, you just get it from the question. And also H lah. Okay, so you already have your X. So now you want to find your Fx. Your Fx for each. Okay, so Fs naught mean Fs naught lah. Fs1, Fs2, Fs3, and also Fx4. So how to get all this value? Okay, refer back to your question. They have a function given, right? So what we do is just substitute lah all these values 0 inside that function, 0.2 inside that function, and then so on. Complete this one, so you will get 0.2, 0.1328, 0.2896. Okay, make sure up till 4 decimal point. 2.5904, and the last one is 12.0272. Done. So now we're back to the formula. Okay, the formula here is fx0 plus fx4. Okay, the first point x0, the last point is x4. So fx0, fx4. And in the middle one we have s1, s2, s3. So 2fx1 plus 2fx2. Kita cukup ruang pula. Okay, plus 2fx3. Okay. So you just substitute the value that you have. So h is 0.2. Okay, fx0 is 0.2 plus 2 times fx1 0.1328 plus 2 fx2 is 0.2896 plus 2 times 2.5904 and plus 12.0272. Okay, make sure yang between, in the between je yang you multiply with 2. The rest or the first and the last point just original itself. Okay, so you can solve this one using a calculator. Calculate carefully, so you will get 1.8253. Okay, alright. It's easy, right? Senang kan? Okay, sebab dia tak ada pun yang you kena buat. Yeah, for me, for the numerical, it's simple compared to the analytical one. Kalau analytical, like let's say lah, macam you belajar the previous week, substitution, by part, right? It's more complex lah compared to numerical, because numerical is nothing. You just find data by using calculator and then substitute into the formula, and then you will get the answer. Okay. Alright class, so means we are done for the trapezoidal. So this is the one of the examples. So if you want to do another example, you can find any sources in the Google, YouTube, or yeah, anywhere you can find it. Okay. So in the next video, I will continue with another two. So we will continue with the same sense. Okay.